Welcome back to AI Podcast. I'm Brian, and we're diving back into the world of AI voice synthesis. This is part 4 of our 10-part series.
Yeah.
And, we've got Kathy here again,
Back again.
ready to kind of break down the magic behind these incredibly realistic synthetic voices we hear everywhere.
It's great to be back, Ryan.
Yeah.
And yeah, things are about to get super fascinating. The last few episodes were like understanding the ingredients and the tools.
All right.
Today we're going to see how those pieces come together to actually like bake the cake,
Okay, so if I'm craving a delicious AI-generated voice, what's the recipe?
Think of it as a pipeline,
Okay.
a step-by-step process with 3 main stages:
Okay.
text processing, acoustic modeling, and the vocoder.
Ooh, I like that. I like the cooking analogy.
Each stage is like a specialized chef with a unique task.
Okay, let's start with that first chef in the kitchen. Text processing. What are they whipping up?
Imagine you hand this chef a recipe, which in our case is just plain text. Their first job is to make sure the computer understands what those words mean. Kind of like translating from human language to computer language.
So it's not just about reading the words, but understanding the intent and the nuances?
Exactly.
Yeah.
And this involves a few key steps.
Okay.
The first one is called tokenization,
Yeah.
which might sound familiar if you've ever dabbled in natural language processing.
Right.
It's basically about breaking down the text into smaller units, like words, phrases, or even punctuation marks. Think of it as carefully chopping the ingredients before you start cooking.
Makes sense. But chopping isn't enough, is it? You need to make sure all the ingredients are prepped and consistent.
Yeah, you got it.
Right.
That's where normalization comes in.
Okay.
It's all about making sure the text is in a format the computer can easily digest. For example, expanding abbreviations like doctor to doctor, or converting numbers like 10% to 10%. It's like making sure all your measurements are consistent. You wouldn't want to use teaspoons when the recipe calls for tablespoons.
Right. Consistency is key, especially when you're working with a precise machine like a computer.
Exactly.
So now the computer has all these neatly prepped ingredients, the tokens,
Right.
but how does it know how to pronounce them? That's where our next chef comes in, right?
That's right.
Okay.
Phone prediction is where we really start getting into the sound of language.
Okay.
Remember from our earlier episodes, phones are the basic building blocks of sound, like the individual sounds that make up a word.
Right.
This chef is responsible for figuring out the right sequence of phonemes for each token, making sure the computer knows how to pronounce each word.
So it's like teaching the computer the phonetic alphabet.
Yeah,
Making sure it knows the sounds associated with each letter or combination of letters.
exactly.
And this is particularly important for tricky words with multiple pronunciations, like read,
Yes.
which can be read or read depending on the context.
Exactly. The chef needs to be a bit of a detective, figuring out the right pronunciation based on the surrounding words and the overall context.
Impressive. It's like the computer is learning to decipher the code of human language, understanding not just the words, but the way they're supposed to sound.
Yeah.
But there's more to speech than just pronunciation, right?
Uh-huh.
There's rhythm, emphasis, pauses, all those things that make speech sound natural and engaging. What's happening in the kitchen to take care of that?
Well, for that, we have our third chef in the text processing stage.
Oh.
Prosody analysis.
Okay.
Think of them as the one who adds the flavor and spice to the dish.
Okay.
They're looking at the bigger picture, analyzing things like punctuation, sentence structure, and even the emotional tone of the text.
So they're figuring out the timing, the intonation, the pauses,
Yes.
all those things that make a voice expressive and engaging. It's like they're adding the music to the language, making it more than just a robotic recitation of words.
Exactly. Remember how we talked about the difference between a flat, monotone voice and one that's full of life and expression?
Right.
That's what prosody is all about, and this chef is making sure the computer captures those nuances.
So text processing is like a 3-chef operation.
Yeah.
Preparing the ingredients with tokenization, ensuring consistency with normalization, and then adding the flavor with prosody analysis.
And once those chefs are done, we move on to the next stage of our pipeline, acoustic modeling.
Oh, okay.
That's where things get really interesting.
Right.
Because we're starting to create the actual sound.
Okay, I'm ready to hear about this. Let's
Get into it.
let's get into it. But
All
first,
So we've prepped our text with all that careful work from our text processing chefs.
right.
Now it's time to move on to acoustic modeling, where we take those linguistic instructions and start turning them into actual sound. And remember those spectrograms we talked
Yeah.
about, those
Yeah.
visual representations of sound? That's where they really come into play.
Yeah, they're like a fingerprint of the sound showing us all the frequencies and intensities
Right,
that
exactly.
make up a particular sound.
Yeah.
And in acoustic modeling, we're essentially creating a blueprint for sound, a detailed plan for how those words should be spoken.
Yeah.
And the key players here are those powerful neural networks we discussed before.
Yes.
Specifically, sequence-to-sequence models like Tachytron.
Exactly.
Yes, Tachytron. We explored that in detail in one of our previous episodes.
We did.
And it's like the master chef in this stage,
Yes.
taking all those carefully prepped ingredients from text processing and figuring out how to blend them together to create the right sound.
Exactly. Tacotron is trained on massive amounts of data,
Right.
text and corresponding audio,
Right.
and it learns to map those sequences of phones and prosodic information
Uh-huh.
to spectrograms.
Okay.
It's like it's learned to speak by looking at and understanding those visual representations of sound.
So it's almost like Tachytron is learning to read sheet music,
Yeah.
but for speech.
Yeah.
It sees those phonetic notes and understands how to create the corresponding sounds.
That's a good way to think about it.
But there's more to it than just creating a spectrogram, right? How does the system ensure that the speech flows naturally?
Yeah.
That it have all the nuances of human speech?
That's where things like duration prediction and prosody adjustment come in.
Yeah.
These are like the sous chefs in the acoustic modeling kitchen, refining the recipe and making sure everything's just right.
So it's not just about what sounds are produced, but how long they're held, where the pauses are, and how the pitch and intensity change over time.
Exactly.
These are the things that give speech its natural flow and emotional expression.
And you're right to connect this back to prosody.
Uh-huh.
Those cues we identified in the text processing stage, the rhythm, the emphasis, the pauses, they all need to be reflected in the acoustic model.
It's like taking those musical notes and adding the dynamics, the tempo, the phrasing.
Yeah.
That's what makes music or speech come alive.
Yeah.
So we've got this incredibly detailed blueprint for sound, thanks to the acoustic model and all of his talented chefs. What happens next? How do we actually hear these sounds?
That's where our final stage comes in, the vocoder.
Okay.
This is where we take that spectrogram and
Yeah.
turn it into actual audio we can hear, like the final step in our recipe, taking all those perfectly prepared ingredients and baking them into a delicious cake.
Okay, I'm ready for dessert. We've journeyed through the intricacies of text processing and acoustic modeling.
Yes.
And now it's time for the grand finale,
Oh.
the vocoder.
Right.
This is where we take that detailed sound blueprint, that spectrogram, and turn it into the audio we actually hear.
It's like taking that perfectly crafted cake out of the oven and presenting it to the world.
Okay.
The vocoder is the maestro of this final stage, taking those complex frequency patterns
Right.
encoded in the spectrogram
Yeah.
and transforming them into audible sound waves that reach our ears.
So if the spectrogram is the musical score,
Yeah.
the vocoder is the orchestra bringing it to life.
That's a great analogy.
Yeah.
And there are different types of vocoders, each with its unique approach and strengths. In a previous episode, we talked about WaveNet,
Right.
a groundbreaking development in TTS,
Yeah.
using a powerful neural network to model the complexities of human speech.
Right. WaveNet. It was a real game changer, generating remarkably realistic and natural-sounding speech. But if I remember correctly, it wasn't without its limitations.
Exactly. WaveNet, while impressive, required significant computational power,
Yeah.
making it challenging to deploy in real-time applications like virtual assistants or interactive games.
Right.
Think of it as having a symphony orchestra in your pocket. Amazing sound, but not very practical for everyday use.
So there was a need for more efficient and faster vocoders.
Yeah.
Ones that could deliver great quality without needing a supercomputer.
Precisely. And that led to the development of other neural vocoders like WaveGlow and HiFiGen. These newer vocoders offer a balance of speed, efficiency, and audio quality,
Right.
making them ideal for a wider range of applications.
It's like we've gone from a full symphony orchestra to a more streamlined ensemble.
Yeah.
Maybe a string quartet or a jazz band.
Yeah.
Still incredible music, but more adaptable and accessible.
You got it. This evolution of vocoder technology has been crucial in driving the widespread adoption of AI voice synthesis.
Right.
It's what allows us to have those natural-sounding interactions with virtual assistants, enjoy lifelike narration in audiobooks, and even explore personalized speech therapy tools.
It's amazing to think how far we've come from those early days of robotic-sounding synthetic speech.
It really is.
The voices we hear today are incredibly realistic and nuanced.
Yeah,
And it's all thanks to the advancements in each stage of the TTS pipeline,
right.
from text processing to acoustic modeling and finally the vocoder.
It's a true testament to the power of AI
Yeah,
and the dedication of researchers and engineers constantly pushing the boundaries of what's possible.
absolutely.
And this is just the beginning. The field of AI voice synthesis is constantly evolving with new breakthroughs emerging all the time.
So as we wrap up this episode of AI Podcast, let's
Yeah,
do a quick recap for our listeners. We started with text, prepped it for the computer to understand with text processing,
right.
created a detailed sound blueprint with acoustic modeling,
Yes,
and finally used the vocoder to transform that blueprint into the audio we hear.
exactly.
It's a fascinating journey from text to speech, and we've explored every step along the way.
We have.
And remember, this is just part 4 of our 10-part series on AI voice synthesis.
There's more to come.
There's so much more to explore, from the ethical implications of this technology to the creative possibilities it unlocks.
Yeah, it's going to be good.
And speaking of exploring further, part 5 of our series drops tomorrow evening.